Welcome to the 67th video in our series about Unix tools. This video uses the same code as the 66th video. Let's draw a dependency graph on the left-hand side of the screen that shows how the various files are related. And you can see an ugly ASCII art graph on the left. At the top is myprog2. That's the application we want to build. And it has lines going down to the two files you need to build it, myprog2.0 and mysubs2.0. And then, if you want to build myprog2.0, it needs the two children, myprog2.c and mysubs.h. At the same time, if I wanted to rebuild mysubs.o, it needs two children also. And you'll notice that myprog 2.0 and mysubs 2.0 both need this header file. And that's why this is a graph and not some kind of tree, because we can have these complex relationships. How do I take this picture and create some file that represents the same thing? You'll see it on the right. So let me show you the structure. Take this top thing, write it down, put a colon. I can't really mark it. Put a colon. And then this has these two children. So you write those two children right here. Then put a blank line. And then for this one, copy it over here. And this one needs two children. There they are. So write them down. Finally, I need this one. So put it here. Put a colon. And then take the children and write them down. But you notice when you write down the children for a .o kind of file, you always put the .c first. Then you can put all the .h's. The other thing you'll notice is I didn't show in the graph or in the alternate representation of the graph system headers. I didn't show those, like standard IO and standard lib. The things that where you include, you use less than, greater than. System libs are taken care of magically by C. But when you do an include with double quotes for a local header file, which in this case is mysubs, it does need to get listed as a dependency. Okay, if you do this, I can't really, let's see if I can do it. I'll use the Control V. There we go. Yeah, sneaky. So if you put that in a file, it represents the same dependency graph that our picture did. But this is nice text that Unix can process. Put that in a file, and the name of the file is makefile. Okay, if you do that, and you do it right, this is what we should have. I've done the set list in VIM so that I can see that there's a tab here. This is a space. These are spaces. But after the colon, can I get just the colon? There we go. After the colon, you need a tab. Remember, that represents a tab. And then these are new lines. So I need a blank line in between each one of these. I need a blank line at the end. And you have your left-hand side, which make calls a target. And then you have these dependencies in a space-separated list. In between those two, you have the colon tab sequence. Okay, once you've created that, you have a makefile. The problem is it represents the dependencies, but it doesn't tell you how to compile anything. So we have to come down here to the next step. The next step looks like this. And you can see that after I've shown a node and its children with that colon tab separator, then underneath there I can have one or more lines, and this file is simple. Each one is one. But you have to start it with a tab, and then you put the thing we typed before. If we want to build myprog2, that's what we need to do. It's called a rule in a makefile. Okay. For some reason, I just showed you the link. So this is the link that depends on .os. That's the link. Here's a compile. myprog2 needs these two files to build, and this is how you do it. mysubs2, it needs these two files to build, and this is how you do it. And this is how you do it always has a tab at the beginning. In between the what you want to build and the files you need, you have to have a colon and a tab. And then these $signs, remember, those are new lines. So save that thing. And if you need to remove any .os in your old myprog, so all you have is source code. If you type make, you'll notice it automatically knows how to build it. And we'll run it and it'll work. So that's a lot of talk. Can I save some typing? Sure I can. Start here. Come down to here. I'm going to use the EX commands, right? From A to here, write, overwrite any kind of makefile you might have. And it says I've got 9 lines in there. So let's open up makefile, and I need to save this file. Okay. There's my makefile, but you see I don't really have set list. I have to undo that. So let's do some quick changes. I'm going to change every $sign at the end of the line to nothing. And then I'm also going to change every #I to a real tab everywhere. And then if I turn on set list, it looks the same as what we had. But set no list, there we go. Leave that blank line at the end, we want it. Save that. Okay, the next thing to do is make sure that you don't have any of those old object files, because we need to start clean. Okay, so they're all gone. If we take a look, we've got our makefile, and we got our subs C, our subs H, and our myprog2. We're ready to go. If we type in make, it built it, and we can run it. That was a lot easier the second time we do it. And if we do make again, he's smart. He says, I'm up to date. Nothing needs to be rebuilt. If you remember in the last video, I showed you how to compare times. And make does that. When makefile starts, it starts on this top rule. And then it says, hey, do I need to rebuild this? Well, is that newer? No. Is that newer? No. And then make stops. It's finished. If this one was newer, how do we know that this one is okay? Well, you have to do recursion. You start here and you check this one. But before you accept this one, you go look and you say, oh, that one I might need to rebuild it. So is this newer? Or is this newer? No. So this is okay. So this is okay. And then he looks at this one and he says, ooh, okay, check that out. Are any of these newer? All of this is based on time. Let's make a change. Let's go into mysubs.c and change this to 3. If I type make, what should happen? Make should look at that dependency graph, and he's pretty smart. He's gonna figure out you changed my subs.c. And if we look at this, my subs.c is here, which is here. And he says, oh, that's new. I got to remake this. And then he's going to look at this and he's going to say, no change. Recycle this one. Make this one. Recycle this one. And then when he gets to this one, he says, recycle. And I already remade this one, but this one is now newer. So I need to do two things. I need to do this, and I need to do this, but I can skip this other one. Let's see. Did just what I said it would do based on the dates. And our graph, which we recorded in the make file, together with the rules on how to rebuild each node from its dependencies. So that completes creation of the simplest kind of makefile you can do. And it did automate things, and it not only made it automatic, it made it smart. We only rebuild what we have to rebuild, and then we link it, but we don't do anything. If I do it again, he says, I don't need to do anything. You didn't make any changes. So please come back next time. I'm going to show you how to improve your makefile using makefile variables so that it works even better. But for now, thank you for listening.